Students, this is lesson U6A03a. By the end of the lesson, you should be able to say, I can solve for arcs and chords. So let's get through some of the concepts that you will need to be successful in completing some of the exercises that accompany this lesson. So the first concept is, what are chords? Well, chord are lines that we draw from one point on a circle to another. So in this diagram here, A, B, C, and D are chords. The longest chord in a circle is a diameter. This is actually a corollary of the theorem that we had talked about in the previous lesson, which was congruent arcs intercept congruent central angles, or congruent central angles will have congruent arcs. So as a corollary, okay, we can talk about not only the central angle, we can talk about their chords. So what we're saying here is, if these arcs are indeed congruent, then that means the chords that are formed by these arcs are also going to be congruent. And then the flip side is also true in reverse, right? So if we have congruent chords, then therefore we're going to have congruent arcs. Let's talk about the second of three concepts. So here in this case, if we have congruent chords, okay, so chord A, B, C, D, and D, E are all the same, then they are in fact going to be the same distance away from the center. So this actually can be shown to be true, because if we have congruent chords here, if I create these isosceles triangles where all of these sides, okay, are the length of the radius, it can be shown that these three triangles are in fact going to be congruent to one another, and therefore will have congruent altitudes. And it just so happens that these altitudes are the distances, okay, that the chord is away from the center. So yes, as a matter of fact, congruent chords are going to be equidistant from the center. So my mistake, there's only two major concepts in this lesson. All right, so let's take a look at this. Pause the video to see if you can figure this out. So hopefully you guys had some time to think about this. I immediately noticed that AB is 110. If AB is 110, BC therefore is also 110, as the given as a given statement here suggests. I know that AB is equal to 3x minus 5, and BC is equal to x plus 5. So now when I say AB, I mean the chord AB is 3x minus 5, and chord BC is x plus 5. And I also know that chord AC is 2x plus 3 halves. How can I find out what is the length of chord AB, BC, and AC? Well, as it turns out, because arc AB and arc BC are the same, we can therefore say congruent arcs will intercept congruent chords. So AB is in fact going to be the same as BC. So therefore we can say 3x minus 5 is equal to x plus 5. Subtract x and add 5 to both sides. We end up with 2x is equal to 10, or x is equal to 5. My goal is to find out what is the length of chord AB, BC, and AC. So therefore I'm going to substitute x back in. So I know that AB therefore is going to be 10, BC is 10, and AC is going to be 10 plus 3 halves, or 11.5. Pause the video to see if you can figure this next problem out. So hopefully you guys had some time to think about this. We know that from the given information here that chord AB is 5 and chord BC is 5. So I'm just going to mark this with congruent symbols there, so with those tick marks. And I have arc AB and arc BC is given by those expressions. So immediately I know that arc AB and arc BC will be the same, because congruent chords intercept congruent arcs. If that's the case, then we can say 40 minus x is equal to 2x plus 10. I can then add x and subtract 10 from both sides. I end up with 3x is equal to 30, or x is equal to 10 once again. If x is equal to 10, I can then figure out what is arc AB. Arc AB is equal to 40 minus x, which is 30. Arc BC will also equal to 30. Arc ADB, or angle ADB, congruent arcs will have congruent central angles. So therefore, angle ADB will equal to 30 degrees, and angle BDC will also equal to 30. Let's take a look at the next problem here. So pause the video to see if you can figure this out. Upon inspection here, I immediately noticed that chord AB and chord CD, they are equal in distance away from the center. They are 5 units away. So immediately I can tell that chord AB and chord CD should be of the same length. So therefore, x plus 3 will equal to 4x. Subtract x from both sides, we end up with 3 is equal to 3x. Divide by 3, x will equal to 1. If x is equal to 1, I can then figure out what AB is. AB, therefore, is equal to 1 plus 3, which is 4, and CD is also equal to 4. All right, moving on. Last question. So here in this problem, you're told the length of the chord WX is 10, length of chord YZ is also 10. So because the chords are of the same length, we then know that QP and RP are going to equal one another. Pause the video to see if you can figure this out. So I know that PQ is equal to PR. So therefore I can say 2x plus 3 will equal to 5 plus x. Subtract x and subtract 3 from both sides, I end up with x is equal to 2. Since x is equal to 2, I can then figure out what is the distance that WX and YZ is away from the center. PQ will have a length of 7, because it's 2 times 2 plus 3. And I also know that PR will also equal to 7, because it's 5 plus 2.